Hey, graduates, long ago and not so long ago, metal fabrication, welding, um, back on the concrete floor, just kind of bringing you back to some of the lessons that I shared with you uh, while we were learning and doing and building and welding and forging and hammering on the concrete floor. I still want to stay part two series with hydrogen, embrittlement, and what it does to us. But before that, I want to do like a public announcement. This is a magazine that you also get the welder through the fabricator. This is free. I would encourage you to sign up, go online, and get this publication each month. And then this way you can stay updated with welding articles and professional journal stuff. Also, I would encourage you to join the AWS, the American Welding Society, and receive the Welding Journal and being able to be a network of welders and engineers and NDT people. It's just a smart thing to do if you're a welder, you're a fabricator, and you are making a career in the world of welding. With that said, part two series, I want to talk about what is the danger of hydrogen cracking, hydrogen embrittlement, delayed hydrogen cracking. Sometimes it can be 24 to 48 hours to 72 hours later. It depends on three elements that we talked about back on the concrete floor. And those three elements are, I believe, you need stress, you need hydrogen itself, and you need the microstructure. And the microstructure is nothing more than the grain boundaries, the molecular structure, the carbon content, the alloy content. So below the surface of the metal, in simple sort of terms. So if you think about what we do with our welding certifications or welding qualification test, which is A36, which is really low carbon steel. It's 0.3 carbon, and it doesn't have enough points of carbon in it to make a difference in cracking or embrittlement. All the steel that we use, like this, or a flat bar, which is usually like a 1018 or a 1020, all the creative things that we have done throughout the years, is all mild, low carbon steel. It does not have enough points of carbon in it to make a difference. But when you get to medium and you get to high, that's when you start to really need to pay attention to the microstructure. And what I mean by that is there needs to be a preheat, there needs to be a post-heat, and there needs to be interpass temperatures, meaning you just can't run through it and get the job done quickly. So with that said, you need to use a low hydrogen electrode, whether it's a flux core or whether it's a 7018. We talked about the H4R factor. That's a reduction of moisture of hydrogen and the resistance of hydrogen. And then when you have electrodes like this, in a day like this, it's 90 degrees in New England, you lay that on the steel table in a hot shop, it will pick up hydrogen moisture, water. So if you're doing critical work, like code work, bridge work, anything that requires strong integrity for customers, and it's not mild steel, it's not 0.3 or 0.4 carbon content. When you're up into the 0.6 to 0.8 to 1%, and then beyond that, you need to start thinking about low hydrogen electrodes. And that also could be in your flux core, even in your solid core. It's a great habit to have these containers, which are sealed. If you're using your flux core wire, wrap it up over the weekend, or if you're not using your flux core, it's going to sit in the truck for several weeks. I would wrap it up, seal it up, to try to minimize moisture pickup, which is hydrogen. So once you get to materials that you see like this, or like gears, or cutting edges on heavy equipment, you need to start thinking about how do you store your low hydrogen electrode. You need to either have a hot box. They have portable hot boxes. They have hot boxes. In fact, my first steel shop in the Navy some 47 years ago, we used a refrigerator with a heat lamp. That will suffice. You just want to be able to keep your wire away from hydrogen moisture pickup. Sometimes you can even store it in your house where there's a better ambient temperature. I know the chief was always talking about a lifetime of learning. Here's a book that was given to me by an old mentor of mine. It was written in 1927. It's How They Made Steel and what steel is all about. And believe it or not, this is a great topic right here. And that is the spark test. And the spark test, as you know, we did that on the concrete floor. I would often show you the carbon content, the spurs, from cast iron to titanium, to mild steel, to medium carbon steel, to high carbon steel. I'd even take a file and put it on the wheel just to sort of evaluate and become like a little detective and say, this is the carbon content of this material. Lots of times if you're self-employed or you're working in a shop, a project comes in, you don't know what that material is. There's several methodologies that you can use, and one of those is the magnet test, obviously. And that goes to ferrous material and non-ferrous material. Everything from aluminum to magnesium is non-ferrous, and everything else is going to have a magnetic pull to it. Some of your stainless steels, obviously your austenitic, will have a non-magnetic pull to it. The magnet test, the spark test, as we talked about, the visual test, and sometimes the weight test. You can tell the difference if magnesium is going to be lighter than aluminum, or you can look at cast iron, perhaps, on the spark test. Will instantaneously identify that it's cast iron. So it's good to have, a copy of something like that in your toolbox or your notebook, because it gives you the nomenclature of the material you're about to weld or about to bend, you're about to work. So if you come in contact with steels and you don't know what they are, that's a good recipe right there for troubleshooting, problem solving, and obviously always having critical thinking. All right, graduates, long ago, just recently, and all the above, in between, keep wearing your safety glasses, your hearing protection, your sleeves. I know it's hot in New England when you're welding, but melanoma cancer does slip in with ultraviolet rays. So keep doing what you're doing. I'll keep talking about these series and revisiting what we did in our lessons back on the shop floor. Okay, seniors, graduates, long ago, not recently, and recently. So over and out. Good to see you.